In the last example, what was demonstrated to you was finding the stationary points, determining whether those stationary points are maximum or minimum, and finding inflection points as well. Now, what was not shown to you though was how to determine for what values of x a function is increasing or decreasing. So that's one of the things that we'll be showing you in this video. So let's get right ahead on that. So before we do that, let's do the normal thing, which is to actually find the stationary point of a given function. So we have the function y equal x cubed plus 3x squared. So dy by dx, as I'm sure you know already, if you haven't done it before me, is 3x squared plus 6x. That's dy by dx. Now, let's find the stationary points by equating this function to 0 and solving for x. So, let's say this is 3x, open bracket, x plus 2 is equal to 0. So that is implying that x is equal to 0 and x is equal to negative 2. So those are the values of x for which the gradient of this function, or the instantaneous rate of change at this function, is 0. Those are the stationary points. Now, let's determine the nature of these stationary points. What do? We say d squared y by dx squared, which is the derivative of this here, the first derivative, would be equal to 6x plus 6. So people, let's do some substitution. Let's clear right here. So, let's clear right here 2. Can we? Yep. So let's substitute our stationary points in this function here to determine whether or not they are maximum or min. So at x equals 0, we would have 6 times 0 plus 6, which is equal to 6. At 2, or rather negative 2, we would have 6 times negative 2 plus 6, which would be equal to negative 12 plus 6, which is equal to negative 6. So that implies to us that at x equals 0 is a minimum and x equals negative 2 is a maximum. So we have come to find the minimum and the maximum values of this function. So now let's go on a clean page. And what we need to do is to write, we need to take note of the first derivative, which would be 3x squared plus 6x. And we're going to be taking note too of the stationary points. X equals 0 and x equals negative 2. Now, what do we want to do? We want to find out where this function is increasing and where it's decreasing. So as we learned, we know that this function is decreasing where the first derivative, this expression here, is less than 0, and it is increasing when that very same expression is greater than 0. So we take our first derivative, dy by dx, which is equal to 3x squared plus 6x, and we're taking our stationary points. That would be x equals 0 and x equals negative 2. And we remember that at x equals negative 2, that is a maximum point, and at x equals 0, that is a minimum point. Now, what we want to find now, we need to determine where this function is increasing, where, remember, the original function is y equals x cubed plus 3x squared. That's the function that we want to find where it is increasing and where it is decreasing. We know that it is increasing for values of the first derivative, this expression here, that render it less than 0. That's when it is decreasing. It is increasing when this expression here, let me circle it again, is greater than 0. So let's go about doing that. For what values would 3x squared plus 6x be greater than 0? And for what values would it be less than 0? To determine that, we can't just solve as though it were an equation. This is an inequality. We're going to be exploiting certain properties of the graph that we know. If there's a stationary point, then that stationary point would have to be between the increasing part of the function and the decreasing part of the function. So let's see how we exploit that property. So we're saying we need to determine whether the function is increasing or decreasing for values less than -2, for values greater than 0, and for values between -2 and 0. So let's look at those values that are less than -2, between -2 and 0, and greater than 0. And we're going to be seeing, because let's say right here that this would be 3x, and that would be x plus 2 rather, is greater than 0. So let's factorize this a bit more. Let's take out the x, leaving us with 3x plus 6, which is greater than 0. So we're going to be having x, 3x plus 6, and the product of x and 3x plus 6, right? So this is how we're going to be exploiting these properties now. So how do we use this table now? Well, right here, we're being required to provide values of x that are less than 2. And plug them in these functions on this side and determine the sign of the output, whether it be positive or negative. So for any value less than -2, if we plug it in this here, we would always get a negative number. For any value less than -2, let's say -3, we plug it in this. What do we end up with? We end up with still a negative number. For any value less than 3, or rather less than 2, that we plug into this. Do we need to plug the value into this? No. Why? Because this right here is merely the product of this function and this function. So whatever output this gives would be the output of this one times the output of this one. So since this is negative and this is negative, then the output of this would be positive. So let's look at this one right here now. Let's choose a value between -2 and 0. We're going to be taking -1. So this would still be negative, this would be positive, and so this would be negative. A value greater than 0, this would be positive, this would be positive, and this would be positive. So what is that implying to us? This is implying to us that for values less than -2, we're going to be looking, let me show you exactly where we're looking in on this table now, because these are the values that we're interested in looking at. This table is implying to us that for values of x that are less than -2, the function is increasing. For those values between -2 and 0, the function is decreasing. And for those values greater than 0, the function is increasing. So now you should be fully well and able to determine the stationary points of a function. You should be able to determine the nature of those stationary points. You should be able to find possible inflection points, and you should be able to determine whether or not a function is increasing over an interval.